4.6 related rates. Your objective for this lesson is to solve related rates problems. We're going to go ahead and jump right into the examples so that you can see what I mean when I say related rates. Example 1. Assume that the radius r and height h of a cone are differentiable functions of t, and let v be the volume of the cone. Find an equation that relates, should be an S, not a D, dv dt, dr dt, and dh dt. So the first thing that we need here is our equation for the volume of a cone. And that is v equals pi over 3 times r squared h. Okay, so this is volume of a cone. If you don't know this formula, you should learn it. Now we're looking for an equation that relates the derivatives of v, r, and h with respect to t. So I'm going to go ahead and differentiate my function. So I'm going to take the derivative of v with respect to t. This pi over 3 is going to stay outside my parentheses. And here I need to use the product rule because I have multiplication. So I know I'm going to have my first term times the derivative of the second, so derivative of h with respect to t, plus my second term times the derivative of the first. So that's going to be the derivative with respect to t of r squared. dv dt is already simplified. I can't really simplify this anymore, so this side is just going to stay the same. Pi over 3 stays the same. R squared dh dt stays the same. Okay, here's where I'm changing. I have the derivative of r squared. Well, I know that that's going to be 2r times the derivative of r, so dr dt. And I'm going to write this so that my derivative part comes last. So plus 2rh dr dt. Okay, so let's take a look. I see dv dt, dh dt, and dr dt all in the equation. They are related with the equal sign. So I think that I'm going to call this problem done. This is my answer. Not so bad. So this was really kind of like implicit differentiation, but I do have multiple variables and I am differentiating for a variable that doesn't actually appear in my original equation. Example 2. Water runs into a conical tank at the rate of 9 feet cubed per minute. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising when the water is 6 feet deep? To solve this problem, we're going to use the related rates problem strategy. So, related rates problem strategy. And this is on page 234 of your textbook. Okay, our first step, and I'll label this step 1, is to draw a picture and name the variables and constants. So I'm going to name my variables and constants first. I know that I have the volume of my tank, so V equals volume. And my unit for this is cubic feet. And this is volume of water in the tank at time t, and t is measured in minutes. Okay, I have x, which will be the radius in feet of the surface of the water at time t. And y, which I will call the depth in feet of water in the tank at time t. Okay, and I've drawn a picture here for you so you can see our tank. So it is a conical tank, and it is 10 feet high. So from here straight down to the ground is 10 feet. I named my variable y, so if this shows the water depth, then this is y, which is my depth of water at time t. X is the radius of the surface of the water at time t, so this would be x right here, from the center outwards. And I also know that the entire tank has a radius of 5 feet. So if you were wondering a minute ago why I decided to assign V for volume, if you're looking at this tank, it is filling up with water. How much water is in the tank is the volume. So the rate at which the water is filling up is related to volume. Okay, so that was step 1, draw a picture and assign variables and constants, name them. So step 2, write down the numerical information in terms of symbols that you have chosen. Okay, step 2. Writing down my numerical information. So at the time that they're asking us about, it says how fast is the water level rising. When the water is 6 feet, means the water level y is 6 feet deep. And my rate of change for my volume is 9 feet cubed per minute. Which brings us to step 3. Step 3 says write down what we are asked to find. This is usually a rate expressed as a derivative. So we are asked to find dy dt. So the rate of change of the water level with respect to time. It says how fast is the water level rising? Water level, t is time. Step 4, Write an equation that relates the variables. You may have to combine two or more equations to get a single equation that relates the variable whose rate you want to the variables whose rates you know. I know, and we used this formula in the last problem, the volume of a cone is V equals 1/3 pi r squared h. But in terms of my variables, this will be V equals 1/3 pi. My radius is x squared, and the height of my water is y. So I'm using x and y because I want to know this in terms of the water as opposed to in terms of the entire cone. Now I'm going to compare what I have in 2 and 3 to what I have in 4. Step 2, this is the information I'm given. I'm given a y and I'm given dv dt. So I have something about v, I have something about y. I'm asked to find dy dt. Notice that 2 and 3 do not mention anything about an x. So we are given no information about x. So we need to eliminate x because we don't have anything about x. We don't have anything about dx dt. So I'm going to go back up to my diagram and I'm going to add a line in here. Okay. So, and I see that I have two right triangles formed by this line that I just drew, the edge of the cone, and my two radii. These are similar triangles. You may remember learning about similar triangles in geometry. If you don't, since I have one triangle here and the segment in the middle is parallel to the segment up top, these are automatically similar triangles. And I can write proportions to relate similar triangles. So that's what I'm going to do. Okay, so using similar triangles, x over y equals 5 over 10. So side x, which is this radius, and side y, which is the height at time t of the water, are both sides of the smaller triangle. So this smaller triangle. Okay. And I can see that x corresponds to 5 and y corresponds to 10. So radius and radius go together, height and height go together, which is why I have x over y equals 5 over 10. So I can solve this for x, get x by itself. To do that, I'm going to multiply both sides by y. You could also cross multiply here if you like to cross multiply better than this. So x equals 5y over 10, which is the same as y over 2. So I can substitute this information into my equation. So really I have v equals 1/3 of pi times y over 2 squared times y. And I'm going to simplify this further. So v is 1/3 times, I'm going to put everything into fraction form, pi over 1 times, I'm going to distribute my exponents, y squared over 2 squared is 4, times y over 1. Now I'm going to multiply everything on top straight across, everything on bottom straight across. So I get v equals pi times y cubed, because I added their exponents, over 12. And this is the same as v equals pi over 12, so it's my constant, y cubed. So now I have my equation that relates my variables that I have information about, my v and my y. My next step, I'm going to start a new page for this, step 5, is to differentiate with respect to t. So since we've assumed that all variables are differentiable to t, I'm going to differentiate that equation that I just wrote with respect to t. So my equation was v equals pi over 12 y cubed. So derivative of v with respect to t is dv dt. I'm going to leave pi over 12 out of this for a second. So pi over 12 times 3y squared dy dt, so that's my chain rule. And now I'm going to simplify by multiplying my constant terms here, because I know that I can simplify that. So 3 over 12 is 1/4, so I get pi over 4 y squared dy dt. And that is equal to dv dt. Okay, so that was step 5. Last step, step 6, is to evaluate. Step 6 says use known values to find the unknown rate. So again, from my previous page here, I see that y is 6 and dv dt is 9 feet cubed per minute, cubic feet per minute. So y equals 6, dv dt equals 9. And I'm going to plug those into my equation that I have right here. So 9 equals pi over 4 times 6 squared dy dt. So this is pi over 4 times 36 dy dt equals 9. Can simplify this, so this just is a 9 times pi, so I have 9 pi. Dy dt. Okay, and I'm looking for dy dt, so I need to isolate this. So let's go ahead and divide by 9 pi. So over here, those cancel, and my 9's cancel. So I'm left with 1 over pi is dy dt. If you wanted this as a decimal, that would be approximately, so dy dt, it's approximately 0.318. Okay, so at the moment in question, the water level, which is what y was, is rising at a rate of about 0.318 feet per minute. And this is the answer to that question. So it is a long problem, but it's not impossible. That is all for 4.6.